We are aware that most of statistics deals with attempting to describe an entire population through the use of a smaller sample. Let's take a look at the population of students attending this college. The average IQ score was found to be 100 with a standard deviation of 10 points. Now we're going to go ahead and take a smaller sample of 8 students and are interested in describing this particular sample. What is the average IQ score of just these 8 students? The standard deviation. Thankfully, we can use information we have already to determine this. If we take enough samples, that is more than one, we notice that the sample means we take a sample of size 8, find the average, and we do that again and again and again and graph the averages we found. We see that this starts to make a pattern. You should recognize this pattern as something you have seen before. In previous weeks, it is the normal distribution or the bell curve coming back again. Patterns are good because they allow us to make predictions. The new distribution of sampling means, or looking at the average of our sample, whether it be the average IQ, average height, whatever variable we're looking at, has a mean equal to the population mean. That is, the mean does not change. The standard deviation, however, must be scaled using the formula sigma over the square root of n, or we take the original standard deviation and divide by the square root of our sample size. This is also known as the standard error value. Once we've found the new standard deviation or standard error, we can use that in our z-score formula, just in place of our original standard deviation, and can find z-scores just like we did before, using the specific data point minus the mean, with the only difference being we divide by the standard error, not the standard deviation of the original population. These can then be used like normal z-scores to look up probability values, either using a table or using Excel. One note, if you want to use Excel, you must first find the standard error and then use that in place of the standard deviation, or where we used the standard deviation before. So let's take a look at how this might work. We had our original population values with a mean of 100 and a standard deviation of 10. That means we know that when we look at a distribution of sampling means, the mean will remain the same at 100, and the standard deviation of the sampling means, or the standard error, will be the original given standard deviation divided by the square root of the sample size. In this case, we're going to look at the sample size of 8, as we showed that on slide number 2. I will take out a calculator, and I will use the square root function. Again, you may use a standard calculator or something on a cell phone, etc., to find the square root of 8, about 2.83, and then divide those two values, 3.53. This is my new standard deviation. Now, you have a choice. If you want to find the z-score, you can, but I want to go right into using Excel. So I'm going to insert a function, and I'm going to use my norm.dist. I know I want to find the probability of greater than 115. My mean was the original given mean of 100. The standard deviation is not the 10 given, but it is the 3.53, or the standard error we found, with a cumulative value of 1, just like before. And nothing changes. This is the probability of less than. Now I need to find the probability of greater than, which of course you can use a standard calculator, or I can turn Excel into a calculator by hitting the equal sign, 1 minus this value. This is a very, very small value. It is 0.00001. That e to the negative 5 means we put 1, 2, 3, 4 zeros and then our 107. Or we shift the decimal place 5 places to the left. This kind of makes sense. A score of 115 is pretty high. It's above average for IQ, and we would have to have all 8 individuals average out above that. So it's probably not that likely to occur, as shown by the probability here. So just remember, when you're dealing with a distribution of sampling means, the average or mean remains the same, and the standard deviation becomes a standard error by dividing by the square root of the sample size. Then you can continue to use Excel or the z-score reference tables as normal.